So the math, we've already kind of talked about the math, but scientists, especially those in design, intelligent design, want to be very conservative with these numbers. So there's probably like each one of these, like some are maybe like 1 out of 80, one is 1 out of 100 that this would happen. But what they do is they just give each one of these 1 out of 10 because they don't want, they're trying to shield themselves from arguments. So we'll be gracious. We'll say there's a 10% probability that each one of these has, and there's more of them that we didn't list here. But if you line all those up, there's about 20 to 25. You end up with a probability of 1 over 10 to the 25th, which is 1 over 1 with 25 zeros behind it. Okay? Very, very, very small chance this would happen. Well, remember when I was talking about there's churches all over doing this coin flip? Well, there's a lot of stars out there. And some people say, yeah, but there's so many stars, this accounts for that. Well, there's only around 10 to the 11th stars. Okay? So if you put 10 to the 11th, I know this is advanced algebra, but if you put 10 to the 11 in the numerator and 10 to the 25 in the denominator, well, you just subtract those numbers. So what's 11 minus 25? 14. So what you end up is with a probability of 1 over 10 to the 14th. So it's still 1 with 14 zeros there. That's the math that you're going to see here on this next video. Can you get the lights for me? Just pause 1 second. Fine-tuning. Fine-tuning. Also going to be covered in this is fine-tuning. So from Wikipedia. Some of the estimated proportions involved in cosmic fine-tuning are remarkable. John Polkinghorne, for instance, pointed out in 1985 that just one factor among many in the cosmos, the difference between an expansive and contractive forces in the expanding cosmos, according to the then accepted theory, depends upon an extremely fine balance of the total energy involved within 1 in 10, that should be 10 to the 60, it should be right in your notes, 10 to the 60, a 61-digit number equivalent to taking aim from the Earth and hitting an inch-wide target at the farthest reaches of the observable universe. Let me just put this in layman's terms for you. Basically, there's all these forces. Gravity is one, that's probably one we all know, but there's like the weak nuclear force, the strong nuclear force, there's the gravitational constant, all these different things that you may have seen in physics where you're solving out, how fast you might fall to the Earth. Those type of things. Those are so fine-tuned that they allow us to have life. And the cosmological constant, which is one thing they're going to be talking about, is the constant that determines with the mass of our universe, are we going to expand forever, assuming God doesn't step in, or will we start contracting and all because gravity pulls things together? And that thing is fine-tuned to like 1 part in a lot, so that we stay constant. We're basically not expanding or contracting in any real way. All right, so let's see the video now.
A lot of things went right on Earth to have yielded complex life, absolutely.
The number of factors that have been postulated has grown. Currently, the typical number you would see is, in a typical list, would have something like 20.
We find that we need to be at the right location in the galaxy, that we're inside the circumstellar habitable zone of a star, that we're in a planetary system with giant planets that can shield the inner planets from too many comet impacts, that we're orbiting the right kind of star that's not too cool or not too hot, that we're on a planet that has a moon that can stabilize the tilt of its axis, that we're on a planet that's a terrestrial planet, a planet that has a crust that's just thick enough that it can maintain plate tectonic activity, that has enough heat in its interior that it's still circulating its liquid iron core so it can generate a magnetic field, that it has an atmosphere that has enough oxygen to allow for complex organisms to survive, that it has enough water and enough continents to allow for the diversity of life for an active biosphere that you need to support complex creatures such as ourselves. All these factors have to be met at one place and time in the galaxy if you're going to have a planet as habitable as the Earth, which you need for complex and even technological life.
In an attempt to estimate the probability of attaining this combination of factors simultaneously, some researchers have developed equations assigning a conservative 1 in 10 value to each factor deemed necessary for advanced life.
If every element has to be there at the same time, you have to multiply the probabilities. And that's what makes the probability at the end so small. You've got 10% of this and 10% of that, and these things rapidly multiply to exceedingly small numbers. The numbers on the order of 10 to minus 15, which is 1/1000th of 1 trillionth. And it's a number like that that you have to compare to the 100 billion stars that are in the galaxy. 100 billion is a very large number, but 1,000th of a trillionth is much, much smaller. On their face value, these probabilities are speaking. What they're telling us is this can't happen, or this is very unlikely to happen in the galaxy. And that's where the evidence is pushing us.
There are many probabilistic resources in the galaxy, but on the other side of the coin are all these factors that you need. You have to get just right in order to have just one habitable planet like the Earth. And that leads me to conclude that yes, we're rare in the galaxy.
Physicists have determined that the cosmological constant is fine-tuned to 1 part in 100 million billion 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 billion. Such precision has been compared to traveling hundreds of miles into space, then throwing a dart at the Earth and hitting a bullseye measuring 1 trillionth of an inch in diameter, an area less than the width of a single atom.
Just consider those two parameters, gravity and the cosmological constant. Their level of fine-tuning is to a precision of 1 part in 100 million trillion, 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 trillion. I mean, that's like 1 atom in the entire known universe.
The fine-tuning of the laws and forces of physics is so precise that few theorists are comfortable invoking mere chance as an explanation, unless our universe is not the only roll of the dice.
If the universe looks like it's fine-tuned for complex life, maybe there's a fine-tuner. Maybe it was fine-tuned for life.
The universe is finely tuned by an intelligence to sustain complex life. An intelligence that must be beyond the constraints of time and space.
All right. So there's your statistics lesson for the year. Oh, some pennies, I'll get those. All right, so fine-tuning and elements from cosmology point to the fact that there is a creator. So basically all these things, the reason these are so, kind of deep and hard to understand is because we have to have, if we're going to say something is so complex that it has to have a supreme almighty God, then these are going to be some complex issues. But basically, to satisfactorily argue this, you have to have several different instances in different places, different proofs, different x's. You remember on our argument, x is complex, beautiful, whatever. So we come up with several different cases where something fits that mold of x.